Welcome to Module 3 of the High Efficacy Lighting for Residential Applications video series. In this module, we'll take a more in-depth look at the Joint Appendix JA8 performance requirements contained in the 2016 Reference Appendices. In this module, we'll discuss light sources that must be certified to the CEC as compliant with JA8 to be classified as high efficacy, relevant lighting terms you should be familiar with, the specific performance requirements for high-efficacy light sources, and light source testing. Let's first look at JA8 certification. In Module 2, we talked about classification of light sources as high efficacy under the energy standards. For this module, we'll be looking particularly at the lamps and light sources that must be JA8 certified. This includes light sources installed in ceiling recessed downlight luminaires, light sources in enclosed luminaires, indoor LED luminaires with integral sources, screw-based LED lamps, for example, A lamps or PAR lamps, pin-based LED lamps, for example, MR16s or AR111s, GU24-based LED light sources, and any other light source which is not automatically classified as high efficacy. Before we dive into the specific qualification requirements for high efficacy light sources, let's go over a few lighting terms so we can better understand the characteristics of a luminaire and the lighting concepts involved. Starting off, let's define efficacy. Efficacy indicates how much light is produced by a lamp or lighting system per unit of electrical power it consumes. It is measured in lumens per watt, or LPW. Greater efficacy values indicate a more energy efficient light source, since more light is output per watt of energy consumed. JA8 requires high efficacy light sources to possess a high lumens per watt efficiency while also delivering a certain level of non-energy benefits such as high color rendering, fast start time, reduced flicker, and a long operating life. Color Rendering Index, or CRI, is the current industry standard for measuring how accurately a light source renders the colors of objects it illuminates. The CRI value is an average of the standard color palettes known as R1 through R8. The maximum CRI value is 100. R9 is another reference color palette used to measure how a light source's spectral output renders vibrant reds. This measurement is especially critical to consider when illuminating items with saturated red elements, including clothing, jewelry, leather goods, and wood finishes. Correlated color temperature, or CCT, is the absolute temperature of a black body whose chromaticity most nearly resembles that of the light source. This means that light sources with a low CCT, 2700 to 3000 Kelvin, emit light with a warmer appearance. Those with a higher CCT, 4000 to 6500 Kelvin, emit light with a cooler color appearance. Dimming is a lighting control method that varies the light output of a source from full light output to off, or zero light output. Dimming also reduces the amount of energy consumed by a light source. Flicker is relative measure of the cyclic variation and output of a light source. In practice, flicker can be visual, or it can occur at frequencies too high for the human eye to detect the variation. Visual flicker is very distracting and can even cause headaches or vision problems in extreme cases. Finally, let's define elevated temperature testing. Elevated temperature testing is a type of testing that manufacturers must do to ensure that their products do not suffer from early failure when placed in luminaires where elevated operating temperatures are common. For example, these conditions are often found in enclosed or recessed luminaires, which can lack good air circulation and ventilation. Now that we're familiar with the lighting terms and concepts for high-efficacy lighting, let's take a look at the qualification requirements for high-efficacy light sources contained in Joint Appendix JA8. In order to qualify as a high-efficacy light source under Joint Appendix JA8, the source must meet certain criteria in the following categories: luminous efficacy, power factor, start time, color characteristics, lumen maintenance, survival rate, dimming, reduced flicker operation, and audible noise. Efficacy requirements ensure that all light sources maintain minimum baseline energy efficiency. To qualify as a high-efficacy light source under Joint Appendix JA8, it must have a luminous efficacy equal or greater than 45 lumens per watt. Light sources with high power factors minimize transformer losses and voltage drops in wiring, ultimately requiring less electricity to operate. The power factor must be equal to or greater than 0.90 at full light output. Start time refers to the amount of time it takes for a luminaire to become illuminated after being switched on. Start time should be no greater than 0.5 seconds to prevent delays between applying power and the start of the illumination. For a lamp to qualify under JA8, it must also adhere to certain color characteristics with regard to CCT, CRI, and R9. For inseparable SSL luminaires, LED light engines, and GU24 LED lamps, the CCT value should be less than or equal to 4000 Kelvin. For all other sources, the CCT value should be less than or equal to 3000 Kelvin. Setting minimum CRI and R9 values ensures accurate rendering of colors and reduces distorted or harsh light, which may cause people to remove the high-efficacy products and replace them with other, possibly less efficient sources in hopes of creating a better visual environment. All qualifying sources must have a CRI of 90 or more and an R9 value of at least 50. Lumen maintenance refers to the percentage of initial light output still being emitted after a 6,000-hour runtime test. To ensure longevity of light sources, the lumen maintenance must be equal to or greater than 86.7% of the initial output after 6,000 hours of use. Additionally, light sources must have a minimum rated lifetime of 15,000 hours. Survival rate requirements also state that 90% of tested units shall be operational at the completion of a 6,000-hour life test. These requirements prevent homeowners from getting subpar products that may be prone to early failure. All JA8 sources must be dimmable. This requirement addresses concerns with lamp failure, flicker, and otherwise poor performance that can occur when non-dimmable lamps are installed in sockets controlled by dimmers. This requirement is also intended to avoid significant consumer dissatisfaction, which happened in the past when non-dimmable CFLs were installed in dimming applications. Dimmable LED-based light sources that dim using a method called forward phase cut dimming must comply with dimming compatibility requirements issued by the National Electrical Manufacturers Association as part of their document, NEMA SSL-7A-2015. LED products that utilize a different dimming protocol are exempt from this requirement. Light sources and specified controls are also required to provide reduced flicker operation when tested at 100% and 20% of full light output. Joint Appendix 10 lists the test methods for flicker measurements. Light sources must adhere to reduced noise requirements in order to minimize humming or buzzing. According to JA8, the light source must not emit audible noise above 24 decibels when measured 1 meter away from the source. These requirements have been put in place to ensure that the light source and lighting system work together to deliver a well-lit residential space and minimize problems resulting from flicker and component incompatibility. In addition to these requirements, JA8 compliant products must also follow labeling requirements to help enforcement agencies, contractors, and consumers easily identify high-efficacy products. These products will either be marked as JA8-2016 or JA8-2016-E. JA8-2016 means the product is in compliance with the general JA8 criteria. JA8-2016-E labeling means that the light source has also passed the elevated temperature life test. This marking indicates that the source complies with all JA8 criteria and may be installed in elevated temperature applications, such as ceiling, recessed downlights, and enclosed fixtures, in addition to any other applications requiring a JA8 compliant source. Manufacturers must test their products at an accredited test laboratory to verify that their products meet all specifications of JA8. The test results and submittal information is then submitted to the Energy Commission to certify that the product meets all JA8 requirements. The tests that must be performed by an accredited test laboratory include efficacy, power factor, start time, color characteristics, ambient temperature life, elevated temperature life, minimum dimming level, flicker, and audible noise. JA8 specifies all testing requirements that must be followed. Manufacturers must submit their product test results using the Modernized Appliance Efficiency Database System, or MAEDBS. Once the results are processed in the system, the product will be listed in the database for use in California. Before we end this module, let's review what we've learned. We discussed light sources that must be JA8 certified. We went over relevant lighting terms and concepts and how they played into the overall qualification requirements for high-efficacy light sources. We learned manufacturers must test the products at an accredited test lab and send test results to the Energy Commission to certify that their products comply with JA8 requirements. This concludes Module 3. For more information on high-efficacy lighting for residential applications, please visit the Energy Commission website at energy.ca.gov/Title 24/2016 standards.